In this video, we will going to take up one more concept on projections of lines, on the introduction of projections of lines. The line inclined to both HP and VP and parallel to profile plane. So in earlier cases, we have not considered the profile plane. Why? Because we used to find the true length either in the vertical plane or in the horizontal plane. So that is the reason why we are not considered the profile plane. But here, in this case, if you see, line inclined to both HP and VP. So line is inclined to HP and also the line is inclined to VP. And therefore, now we need to check whether the line is parallel to profile plane or not. If it is parallel to profile plane, then we need to consider the profile plane also. So that is the reason why we have considered this. So if you see, this is the three-dimensional sketch. How would the position of the line which is inclined to both HP and VP and parallel to profile plane? You can see that capital A and capital B. So this is the position of the line which is parallel to, inclined to HP, so that is this one, inclined to VP, that is this one, and parallel to profile plane, that is the two endpoints of A and B are at equidistance from the profile plane also, that is from here to here and also from here to here. Both the points are at equidistance from the profile plane, that is in front of RPP. Where you can see that in front of RPP, you can see that in front of RPP is seen in the vertical plane, and when you look from the top view, you can see that in front of RPP is also from the top view, that is in front of RPP. So when you look from the front view, the point A is projected to A dash and the point B is projected to B dash. So both A dash and B dash are on the same line. Therefore, you get a vertical line in the front view. And when you look from the top view, that image will going to fall on the horizontal plane. So the point A which is projected here and point B is projected here. Both these points are on the same line. Therefore, in top view also you are getting A and B. But when you look from the side view, you can see that inclination, capital A and capital B. So when it is projected, this projected point will going to be on A double dash here, and also when you projected the point from B, it will be B double dash. You are going to get A double dash and B double dash. So we have joined between capital A and capital B here, and we have joined between small a to small b, because capital A to capital B is joined. Similarly, A dash and B dash is joined, because what I am trying to do is, I am trying to write the image of this in the vertical plane, in the horizontal plane and the profile plane. So therefore, we are joining in the corresponding planes. Now we want to see where exactly you will be able to find the true length. If you see in the front view, you are getting a vertical line. So that means both A dash and B dash are not at equidistance from the horizontal plane. So when you look from the front view, both A dash and B dash are not at equidistance from the horizontal plane. Therefore, the line is inclined. But here, if you see, it is a vertical line, but it is not perpendicular to HP. How do I know that it is not perpendicular to HP? If it has to be perpendicular to HP, then what happens? That line has to be parallel to VP. Now how do I will be able to analyze this? If you look from the left side view, you can see that the line is inclined. Where that line is inclined? Inclined to HP here. That is, to this line is inclined. That is to HP. This line is HP and this line is VP. And also the line is inclined to VP, you can see here with respect to this. So therefore, the line is inclined to both HP and VP. If the line is so, when you are projecting these 2 points, you will get a vertical line. But if you get a vertical line, that means it is perpendicular to HP. If you want to get a vertical line in VP, it should be perpendicular to HP and parallel to VP. But why it is not parallel? If it is why it is not parallel to VP? Because when it is parallel to VP in HP, I should get a point. But if you see here, in HP, you are getting a vertical line. Therefore, the line is not perpendicular. So obviously, it has to be inclined. So you can see that line is inclined to VP. Similarly, if you look from the top view, you have got a vertical line here. But if it is a vertical line, means it should be perpendicular to VP. If it is said to be perpendicular to VP, in VP I must get a point. But what you are getting? You are getting a line in the VP. So therefore, the line is not perpendicular to VP also. How do I will be able to come to know? So one thing is, if the line has to be perpendicular to VP, so then in VP I should get a point, but you are getting a line. So that is the one point. And also when you look from the left side view, you can see that the line is inclined. So the line is inclined to HP. So you can see that inclination here. And so this is an apparent length, this is also apparent length. But where I am getting the true length? The true length where I am getting is in the profile plane. How do I know that you will be getting the true length in the profile plane? Both the points A, capital A and capital B are at equidistant from the profile plane. That is, from this point to this point and also from this point to this point. These two endpoints are at equidistant from the profile plane. How do I will be able to check the distance with respect to the profile plane is always seen in VP and as well as in HP. So that is the reason why we have got in front of RPP in the front view and also in front of RPP in the top view. So both these lines are at equidistant from the profile plane. Therefore, you are getting the true length in profile plane. That is capital A and capital B. And since this is the side view, you are getting A double dash and B double dash. Now what I need to do now? I need to cut it here and rotate HP down and RPP to the counterclockwise direction. We will see that now. So now I have rotated HP down. So what happens? The image is also being rotated like this. So we are projecting these 2 points here and we are getting it interconnected from these 2 points like this. Then you are getting this. So I am just taking the intermediate rotations. I have rotated HP once, then I will be rotating RPP once. So now you can see this is how it will going to come. So here you will be able to identify. Now what I have written? The same thing in the orthographic view. So how to write this? First I should draw the XY line and X1, Y1 line. Since you have the profile plane, therefore you are getting profile plane X1, Y1 and identify the quadrants, that is VP, HP and RPP. Either we can take RPP or LPP. If you take LPP, then LPP will come on this side and VP, HP will be coming on this side. This is VP and this is HP. Then 45 degree will come on this side. Now, I want to start from the profile plane itself. So what I will do? I will consider any distance and I will draw a horizontal line. Similarly, I will consider any distance and draw a horizontal line in the HP also. Now consider any point and draw an inclined line of any distance. You mark this as A double dash and B double dash. Then draw a inclined line here 45 degrees adjacent to HP and you project these 2 points down. And you are going to get these 2 points. Then you draw a horizontal line here and a horizontal line here. And take any distance from X1, Y1 line and draw a vertical line. So since you are projecting from this point, you will get A here and B here. And now you project from here and you project from B double dash and you project from A, B and A to the front view. So you get A dash and B dash, you mark them. So this is how you will be able to write this. Now, how do I know that this is not in true length? Line inclined to VP. Since the line is inclined to VP, therefore in VP you will not be able to get the true length. What is this length? This length is 100, but this length is not 100, and also this length is also not 100. Now this is also not in true length. Why? Because it is true length in HP means what? It should be parallel to HP. But now it is inclined to HP. Which is the HP line? This is the HP line and this is the VP line. So line is inclined to VP, therefore in VP you will not be able to get the true length. Line inclined to HP, therefore you will not be able to find the true length in HP. But both these two endpoints, that is A dash, B dash and AB, are at equidistant from the profile plane. Therefore you are getting the true length in the profile plane, which is capital A and capital B. So this is how you will be able to identify that in any one of the three planes you will be able to get the true length. Now what if I will not be able to get any one of the true lengths in all these three planes? We are going to take that situation. Line inclined to all the three planes. Now you can see you have capital A and capital B, and when you look from the front view, that image will going to fall on vertical plane. This is A dash, B dash. When you look from the top view, this is projected onto horizontal plane, which is A and B. When you look from the side view, it is projected onto A double dash and B double dash, these 3 points. So here, when you look from the top view, the two endpoints are not at equidistant from the vertical plane, therefore the line is inclined to VP. That is in front of VP. And B is at some other distance from in front of VP. Similarly, when you look from the front view, both these two endpoints, A dash and B dash, are not at equidistant from the horizontal plane. This is above HP and B dash is also above HP, but not by the same distance, but it is at some other distance. Similarly, when you look from the front view, the endpoint of A is not at equidistance, or endpoint of B not at equidistance from the profile plane also. B dash is in front of RPP here, whereas A dash is in front of RPP by this distance. Similarly, A is in front of RPP by this distance. B is in front of RPP by this distance. Therefore, in none of these three planes, you are getting the true length. So, I am getting to the left side view. When you project it, you are going to get A double dash, B double dash. So, in none of these three planes, you are not able to get the true length. This is the situation. Now, it is being rotated. Now, you can see here in the orthographic view also. So, is this line is in true length? That is in the top view? No, because the front view line is inclined. Is this front view line is in true length? No, because the corresponding top view is not in true length, not parallel to XY. Is this line is in true length? No, in the corresponding plane, that is both A dash and B dash and AB are not at equidistant from the profile plane. Therefore, in none of these three planes, you are able to find the true length. So, what is the requirement on projections of lines? When the view lengths are given, you need to find out the true length and true inclination. When the true length and true inclination is given, then you need to find out the apparent length and apparent inclinations of the line. This is our exercise in projections of lines. The projections of lines is a very, very important concept that will haunt you in all other chapters of projections of laminas, projections of solids, development of lateral surfaces of solids. In all these three chapters, the true concept of true length and true inclination will play a major role. Therefore, the line projections of lines is a very, very important chapter from the point of view of understanding the concept of engineering drawing. Thank you.